Hey, Algebra 2, the light is funky behind me, so I got the weird close-up. If we go like this, you can't even see me anymore. So one of the tougher worksheets in our packet today, I want to go over number 1 with you from it because I figured you might struggle a little bit. So let's get right into it. One of the worksheets in our packet this week had a lot of word problems on it. And it looks something like this. So this worksheet says to first, before we even start, take a moment to highlight with a color of your choosing. And I have highlighters in class if you need some, but for the function given to you in the word problem. Please take a moment to highlight the function given to you in the word problem. Okay, function, f of x, g of x, m of x, that's what a function is. That's our equation for our function. Okay, next it says with another color, highlight when the word problem gives you what a variable means in the problem. Okay, so anytime I see a variable down here at the bottom, it says where x is the number of years since 1998. That's telling us what the variable is, okay? Now we can go through and we kind of have a jump off point. It says the number of hours people in the United States spent using the internet each year from 1998 to 2001 can be modeled by that function, f of x, where x is the number of years since 1998. Okay, it says graph the function and identify its domain and range. Okay, so we have options here for graphing. Option number 1, if you can look at this and you can tell it's linear, y equals mx plus b, first of all, go give a high five to your Algebra 1 teacher because you remember that that's awesome, that's true. And 2, we can graph it using y equals mx plus b, slope-intercept form. This back number, 54.4, is the y-intercept. That's where our graph crosses the y-axis. So here's our y-axis. It's going to cross at 54.4. So I'm going to put a dot around where I think 54.4 is. Somewhere around there. Okay, next. The slope of this line, linear function, is going to be to rise 26.4 and then run 1. So if I'm already at 54.4, I'm going to rise 26.4. I actually need to go up to 80.8, and then move over 1. So there's 50, 80.8, maybe somewhere right here, and over 1. I'm going to put a dot. From there, we get something straight, and we connect those two dots, and we have our linear function. That would be option number 1 if you and your Algebra 1 teacher are feeling it, because you remember linear functions. Awesome. Option number 2, just plug in the numbers. Plug in our domain. Years since 1998, I could plug in a 0. I could take the x out and put in a 0. 26.4 times 0, 54.4. That would be the first dot. Then I could plug in a 1. That would be 80.8. Then I could plug in a 2. Okay, we're all plug in 2 real quick. 26.4 times 2, plugging in a 2 right here, equals that, and then plus 54.4. Should be 107.2. Okay, 107.2, like right around there. And then I put another dot. And you can just keep putting dots until you have it all filled up. Okay, I'm choosing to connect the dots because years since 1998, 1.5 years could be in there. I mean, that's half of a year. Just a half year could be in there. So if you just put dots, you're just doing straight 1 year since 1998, 1999, 2000, 2001. By doing a line, you're covering all those little pieces of years in between. Okay, that's 1. That's A. Next, it says to find the number of hours people spend on the internet in 2000, and then explain how you found your answer. Okay, so we have, again, 2 methods. We have the graphical method, and we have an equation method, whichever one we feel like we're confident in. Years since 2000, or years since 1998. Remember, we highlighted it in blue up here. X is the number of years since 1998. If it's 2000, that's been 2 years. So I need to go to 2 on my graph and then go up to where my dot was. It was 107.2, so the answer is going to be 107.2, by the way, just because we plugged it in. Otherwise, we can plug it in. We can say f of 2 after 2 years after 1998 will equal 26.4, take the x out, put a 2 in its place. So I'm taking this x out, putting a 2 in its place, and adding 54.4. Well, guess what? It equals 107.2. How I explain how I found it, I would say I plugged in 2 for years since 1998. Nice. Okay. That's A was the graph. Check. B was this, what we just did, 107.2. Finally then, C. C says, when did people spend about 120 hours per year on the internet? Explain how you found your answer. I'm going to do it a different way this time. I'm looking for hours on the internet, so I can look at my Y's. My Y's are internet usage in hours, and I want to go to 120 hours. So I'm going to go up to where it's 120. 120 looks to be right about here, and then I'm going to go over to my graph and down, and it looks like it's in between 2 and 3. So sometime in between 2 and 3 means sometime in the year 2000, between the year 2000 and 2001, because remember, it's years since 1998. So I'll say during the year 2000, there are about 120 hours spent on the internet. Okay. How? Explain how you got your answer. I'm going to say I used my graph. I went to 120 on my y-axis and found the x. Okay? Not as precise as it could be. If we were going to do get a really accurate answer, and a better answer probably, I would just go to my function. F, if for us in this case is internet usage, take that whole thing out and put 120 in. So 120 equals 26.4x plus 54.4. And if I solve that little equation for x, that would be the exact value. Let's see how close we are. To make that happen, I would subtract 54.4 over 120 minus 54.4, and then divide by 26.4. Divided by 26.4, 2.48. And that's what I said, a little bit beyond 2, a little bit after 2, 2.48, so we would have got the same answer either way. Okay, that's the idea. You have 3 more to do on your own. Be careful with that slope. Bring any questions you have to me when we're in class face-to-face, and moving on.